Hiya, how are you? I'm here doing a live lesson on trig graphs, sine, cosine and tangent graphs, drawing them. My classes this week have done some stuff on this, so I'm going to do a live lesson for anyone who wants to see it. If you're watching this live, then welcome to the channel and thank you for joining me and taking part. Feel free to ask me any questions in the chat. If you're watching this later on, which is likely to be for most of you, let's be honest, coming back watching this maybe later this week, maybe later this month, maybe even 6 months' time, then this lesson is about how to draw trigonometry graphs, drawing sine curves, drawing tan curve, and seeing what they look like. So what we're going to do is go straight on with it, and then once the introduction is finished, I will then go straight into showing you how we would go about drawing these. So, here we are. Let's get straight into my whiteboard presentation, and you will see here I'm in front of it, which is really helpful. But with the magic of modern technology, I can shrink myself down to the size of a small pea. And then I can use my whiteboard pen, which I've got here, and I can talk about how we're going to do this. Now, we have here the graph, and we're going to try and draw it. But the weird thing is, we're going to be drawing it between... And let me get this set up properly. There we go. Between 0, 1 and minus 1. And you'll see why shortly. And we're going to draw it every 20, 40, 60. And this goes all the way along. All the way up to 20, 40, 80, 100, 120, 140, 160. Is this one here, 160, 180. We're going to go all the way to 360, so we need to go another 9, 200, 220, 240, 260, 280, 300, 320, 340 and 360 will be there. And you would carry on the numbering all the way along. And what you're going to do is you're going to take your calculator, and in there you need to find the button that says, my one is just here, the sine button, and type sine 0. Close the brackets, and it says when I press equals, sine 0, and that's what it looks like, equals 0. So in the thing here, when I put sine 0, I got 0. Now we're going to try it for 20. Sine 20 says to me that it's got 0.34. So I now put this into my calculator, and this is what came out, 0.342. So I'm just going to write 0.34. And what you do is you repeat this for the whole thing. I'm just going to do the first few so you can see what's going to start happening. So you're going to get 0.64, and you're going to, where as accurately as you can, try to put these on the graph. So 0, 0 is nice and easy. But 20, 0.34, realistically, that's 0.5. And every one of these little squares, which is quite small on the grid, is going to be a decimal point. So when we're doing 0.34, we want 1, 2, 3 little squares. It's going to be about there. And then the next one is going to be 40 and 0.64. We're going to do 0.6. It's going to be about that. It doesn't matter if it's perfect, but we do want it to be nice and neat. And you will eventually get quite a few of these. We'll do one more just so you can see what's going to happen. Sine 60, and that gives me a weird number on my calculator. It says root 3 over 2. So what I then do is I press the S to D button, and I'll get that sine 60 is 0.87. I notice I've rounded that. It says 0.86, but I rounded it. 60 is 0.87, which is nearly 0.9. And you then are going to draw a nice smooth curve through those points. And you carry that on all the way to 360. And you'll have a full table, and all of this stuff is prepared for you in the worksheet in the description below. So all you have to do is click on the worksheet, print it off, start filling in numbers, and it will allow you to do the work yourself and see how this works. I strongly recommend you do these worksheets yourself, because seeing stuff really doesn't embed it in our brains. We only learn about 10% of what we see, 20% of what we hear, 30% of what we see and hear at the same time. So this is that sort of medium. But doing things yourself goes way up to 65, 70%. So doing things for yourself is going to be far better for your knowledge, your retention of that knowledge, and your understanding going forwards. So let's see what happens a bit later. I've put it in the oven. I've left it cooking, and this is the graph you end up with. You'll notice my one goes up in tens here. I've used a bit of software called Desmos, which is an online thing you can use to get graphs up. And this is what the sine curve looks like. And it's called the sine curve because it's y equals sine x. And so we'll have the y up that axis and the x up there. And you'll notice from about here, it repeats. This carries on, and it actually repeats forever. And this carries on that way, and it carries on forever. And it goes up and down and up and down and up and down and up and down. You can even superimpose them on each other. I did this on paper, which you may have seen in the link, and I put the sine curve and the cosine curve on top of each other. If you can just see that there. The purple one is the sine curve, and the orange one is the cosine curve. So we've got the sine curve here, and the cosine curve here. This one starts at 1. Now some people say to me, sir, why don't they all start at 0, 0? And I say, cos. And they say, sir, that's a terrible joke. And I say, I don't care. It is a terrible joke, but it's designed to help you remember which one doesn't start at 0, 0. If you look behind us, there's no one there. So y equals sine x starts at 0, 0. And then if we carry on to cos, it doesn't. It starts at 1. It's like the curve has been moved 90 degrees that way. And then tan is this weird one. It's got nothing to go. It still goes through 0, 0, you can see. But y equals tan x, the green. I have got these bits here. There's a y there, but the x is missing. These are called asymptotes. And what that means is they are places it will never reach. Places that this graph never reaches. I'm just trying to bring up, just in case anyone does any chat in the live thing, I can communicate with them. These are bits, this will get closer and closer and closer together, but it will never be that. And if you put 270 in, you get a maths error in your calculators. But this is what the tan graph looks like. It's just got this weird shape. But you'll be able to do that from the tan one that is in the description in the worksheet. Now, why do we want to draw these graphs? Well, a lot of math starts to be about solving these graphs. They have practical applications, but at the moment, it's a bit like if you came to woodwork and you said, I want to learn how to make a table. And I say, fine. At the end, you will learn to make a table. But for now, I have to teach you how to hammer nails into wood neatly and accurately. And you'd be like, oh, what's the hammering nails into wood got to do with that? Well, we'll get to that. You're going to learn to plane today. Oh, what's that going to do? I just want to make a table. Here, we're learning about how to use these graphs for solving. Let's go back 2 slides. Here's the sine x thing. Now, let's imagine I'm told, don't know why this is moving, I'm told that sine x equals 0.4. So let's say imagine you've finished your worksheet, you've got your lovely neat axis, so your worksheet is complete and you've got your thing. How would I then use it to solve this equation? Well, we need to find where it equals 0.4. And I can see 0.4 over here. So what I do is I draw a straight line from this point here all the way across the grid at the point where it's 0.4. And you will see in this range there are 2 solutions we're interested in. One here. That's not the best drawing ever, is it? And one here. Now, what that means is we need to find 2 answers to this question because there are 2 places. And I reckon reading this across, it's approximately 23 degrees and it's approximately 157 degrees. Even better than that. I spot that there is like a mirror line at 90 degrees. So what I can do, if that's a mirror, the distances have to be the same away from the mirror line. If that's a mirror, then 180, which is this number here, which is one end of the mirror, and this, that mound is mirrored. This distance of 23, if we've got it right, should be the same as this distance here to 180, because that's where the mirror is. And let's check whether that's right. 180 minus 23 is 157. We know we must have got it right. And you can do it that way, actually. You don't even have to read the graph for the second one. You can just take 23 away from 180 and it will tell you the correct sort of pair. All the answers come in pairs. Now, we can do this with negative numbers as well. But obviously, if the answer was a negative, so let's say we had sine x is minus 0.7. When we draw our graph across, and I'll use purple for that again, when we draw our graph going across and we go to minus 0.7, this time the answers are over another side. So I'll draw up to the line as accurate as I can, and I'll draw another one up to the line as accurate as I can. And you can just read off, but once again we can say that the first one looks like it's about 227, but once again there's a mirror line involved. Here at 270 is a mirror line, but it's not a mirror of the whole graph, it's just of this mound from 180. So this distance here must be the same as this distance here. So we're going to try and see how that is with 227. If that's 227 and that's 180, we have to realise that that gap is 47. So therefore that gap must be 47. So if I do 360 take 47, I think its partner in crime is going to be 313 degrees, because it's going to be friends with each other. So that's how you would find the pairs of answers, the pairs of results that go together for the sine x. We can do exactly the same with cosine x. On cosine x, if we want to read off where answers are, we want to, again, just draw across. So let's say it's 0.2 this time. We draw across. But cosine x, it still has two answers but in that range. Notice there'll be infinite answers because we could carry on this curve forever, but we're mainly focused between 0 and 360, which is called the period of the line. We're going to now circle this and circle this, and I think this first answer is about 78 degrees. So we can say if cos x equals 0.2, then the first x was 78 degrees, or there's going to be two answers. Now we could just measure it and it will be about 282, but let's be more precise. There is a line of symmetry, not just here in a little bit, but it's in the whole curve between 0 and 360 here, which is practically quite useful. Because if we now know that this distance here is 78, because that's what we read it as, we also know that this distance up to 360, because 360 is like the end point that we're focusing on, is also 78. So if we know that, 360 take away 78, we know it must be 272. Let's check I've got that right. 282. Let's make sure my math is correct. 272. 272 plus 8 is 280 plus 70 is 350. It's 282, isn't it? It's been a long day. 282, add 8 is 290, add 70 is 360. So there we go. They must be the two answers to this equation. So what we've done lots of equations before where like 9x plus 4 equals 7. It's just another way of doing these, but where cos x is involved. So we're going to get rid of the simplistic form and do them where trigonometry is involved. Now the final one, tan, has some other funky stuff, but it doesn't revolve reflections. It's actually, this is the easier one. Once you've got the graph, it's much easier to use. Because let's say I'm doing where it's equal to 2. I draw across, and let's change the colour of that line to purple because that's where we've been doing our solutions. And hopefully you can all see that yes, there's two solutions again. One here, and one just here. But the cool thing here is, rather than a reflection, it's a repeating. it's got something called a period of 180 degrees. So if that is 62, which is what we'll go with, so we'll say if the question was tan of x equals 2, what is x? We say x is 62, but it's also, we have to put degrees, it's also going to add 180 to that, 242. The gap will always be 180 there. And that's much easier for trig, for tan. So actually, tan is the easiest one to find the other answers to. You can use lines of symmetry to find the other answers, but the tan one is just add 180 and you find the next one. Add 180, find the next one, which is why that's 242. So today's lesson has been about, first of all, how to draw these graphs and what they look like. I strongly recommend you do the worksheets to get these graphs looking nicely yourself. You can fill in all the things. I've got tables for you, and then you've got empty axis where you can do all these things. And then once we've done that, we've talked about how you can read values off of the graphs again. Once you know, say for example, cos x equals 0.3, we can then work out from the graph how that works. Next lesson, next week, on Monday, I'll be doing a video on how to find the solutions without needing the graph, just using your trusty calculator, but using your knowledge of these graphs and a sketch of the graph and talking about the sketches of the graphs too. I hope this has been useful for you. Feel free to put comments, like and subscribe, but feel free to put comments in the description below telling me more of what you liked, what you didn't like, how helpful it was, and anything I can do to improve the video and make it more useful for you. I've been Mr. Harris. You haven't. Look after yourself, take care, and I hope to see you in the next video.